Hello, JSDayIE. It's a privilege to speak on the stage again, surrounded by amazing speakers. As you always seen throughout the day, it's been great. So I'm obviously Chris Laughlin, and I'm here today to talk all things about BUN. So we'll get the whole where you can find me thing in a way. Like I tweet maybe 3 times a year, usually when I'm speaking at conferences, and I'm quiet most of the other time. So you can follow me on X or Twitter or whatever we call it nowadays. I've been recently posting on TikTok under the handle The Dyslexic Developer. So I post short little videos about JavaScript APIs, web technologies, trying to be fun and cool and hip with the kids on TikTok. So if you're on it, check me out. So what is BUN? BUN is a fast JavaScript runtime and many more things. So before we can get into BUN, we first need to look at what a JavaScript runtime is. And we had a talk recently talking around JavaScript runtimes. I was kind of worried we were going to be explaining the same things, but hopefully we'll learn some from both of these. So I recently downloaded a copy of the movie Forrest, and I think the copy I got, he was really heavy into JavaScript and runtimes. So there's this scene where he's sitting on the bench, and he's talking to this lovely old lady, and she asks him, Forrest, what is a JavaScript runtime? And thankfully, in this copy that I got, I know BitTorrent and all that kind of stuff, it explains perfectly. So the JavaScript runtime is a program that extends the JavaScript engine and provides additional functionalities so we can interact with the outside world. It's kind of wordy and it doesn't really actually explain what it is. Nice try, Forrest. Maybe the next copy of the version I'll get will be a bit more in-depth. So when we think about JavaScript runtimes, we can break them down into 2 specific categories. We have our browser-based runtimes. So that's the things that are powering the likes of Chrome, Firefox, Safari. And then we also have the server-side runtimes. So that's powering the likes of Node, Deno, and obviously BUN that we're here to talk about today. So we obviously have these 2 different categories of runtimes, but what does an actual runtime mean? What it is, what's built up of it, what are the inner components? So we can think of the runtime as a container that holds multiple different elements. And so for this example, we're looking at the Google Chrome runtime. So one of the key parts of the runtime is the JavaScript engine, which we learned about earlier today. And some of the core parts of the JavaScript engine is the heap and the call stack. And if you missed the previous talk, the very high-level explanation of what the engine does is it takes the JavaScript code that we write and it executes it on the machine. So it takes all that fancy ES6 code that we're writing day in, day out, and actually executes it on your laptop, your server, whatever you're working with. But we need some more things in the runtime to enable us to be able to do other things. So specific, I can say the word, to the Chrome runtime, we have the web API. So the JavaScript engine, yes, it's built by the Chrome team, and it's actually using the V8 engine under the hood. It's not really aware of the browser and how to interact with the browser, so we need something that allows us to talk to the browser. And here's an example of some of the API calls that it's making. There's a whole extensive list, but things like the DOM, so that's reading and writing from the document object model, so your query selector, write element, all that kind of stuff. It also handles fetch, so being able to make network calls whenever we're building a web application that talks to a backend, there are multiple servers and all that kind of fun. It also handles timers, so that's like a setTimeouts, set interval, so it handles a lot of kind of execution for us, and even the low level of console login, so logging into the browser's dev tools. That's all handled by the web API that's bundled with the runtime. We also have 2 queues, so we have the microtask queue and the callback queue, and these just kind of manage the operations that we're making. So this orchestrates the kind of order whenever you're making calls. So if you're using a set timeout or a promise or just a normal function call, how they're being executed and how they're being stacked into that queue. So it kind of gives you that asynchronous side of JavaScript. But then it's flip side to our server runtime. So the example we're using here is Node. So a lot of the elements are very similar here. So we have the exact same engine. So we have the JavaScript V8 engine. We still have our microtask queue, and we still have our callback queue. But one of the key differences here is we no longer have that web API built in. Because we're on the server, we don't care about the DOM so much. We're not interacting with the browser. So in this case, Node built a set of JavaScript intermediate libraries. So these communicate with C and C++ bindings. So this allows you to do all the fun things we do in Node land, where we write to the file system, read to the file system, host web servers, all that kind of stuff. Things that we don't need to do in a browser, but we'd want to do them in the server. So this is how Node.js allows us to run JavaScript on the server. So we come back to this question again. What is BUN? BUN is a fast JavaScript runtime and many more things. So what does the BUN runtime look like? And we can kind of see some similarities here. We still have our microtask queue, we have our callback queue, but one of the kind of key two differences is the engine that BUN runs. So BUN uses the JavaScript core engine, which is also used by Safari, but this engine is focused heavily on performance and pushing through a lot of data and a lot of information to make actions and operations faster, quicker, allow you to run more in the same time. And then the other difference here is we no longer have the Node.js APIs because we're not using Node anymore. We have the BUN APIs instead. So BUN has built up and replicated a lot of the APIs that we've used in Node, but they are using it in a programming language called Zig, which again is a very performance-focused language, and it's all about like optimizing your memory usage and making sure that you can make operations as fast as possible, and you can call them as many times as possible. Again, this still has the C and the C++ bindings to be able to talk to the machine and read and write from the file system and all that kind of jazz. So we want to get started with BUN. What's the first steps we want to do? If you're on a Mac, which I am, or a Linux-based system, like you can curl the install script. Simple enough, it'll install everything for you, and you'll be up and running in seconds. Funny enough, you can actually use npm to install BUN, so the ecosystems are kind of crossing over together. Or you can use brew to install BUN. It is available for Windows, but I use a Mac, so you'll have to figure that out yourself. So when we think about BUN and what it does, and I think of BUN as a drop-in replacement for npm and Node, so you can kind of remove those from your ecosystem and replace them with BUN. So the first thing you do when you're starting a project or joining a team, you need to npm install, like your dependencies, your packages. And because BUN is this drop-in replacement, they've managed to cover saying, right, well, let's replace all the things you do with Node and npm, but do them with BUN. So BUN has a BUN install command. So I got a Remix starter kit and decided to run BUN install, npm install, and pnpm install. Just wanted to have a kind of third outlier here. And I wanted to track what is the actual speed and performance, because in all those slides I've been saying BUN is a fast JavaScript runtime, and I actually wanted to validate, is this actually fast or not? So you can kind of see it running through here, but we want to get to the actual real data of it. And I'm not a designer, so I use charts from Google Sheets that are basic, but they do the job. So we can kind of see this is the times. The taller the bar, the slower it is. So unsurprisingly, Node is coming out the slowest here. It's notorious that an npm install is very slow, and that's when you usually jump on TikTok to watch some of my videos. And then you go down a rabbit hole and you come back 2 hours later and it's already installed for you. In a close second, I was very surprised. pnpm install was very fast, and I think this is how they're doing it with the kind of caching of their packages. And you have a node modules folder, but it's not really a node modules folder. They're doing a lot of magic there of how they symlink packages together. And then obviously, to prove BUN is fast, BUN came out on top here. And even if you're comparing BUN against npm, we're looking at a 73.5% time increase just from doing an npm install. And this was a fresh npm install. There was no cache packages. Everything was cleared out on my machine. It was very surprising how fast that came out. Now, when we think about how often we run npm installs, that's, yes, saving me time, but I'm not running an npm install multiple times a day. I'm not doing it all, on every project I work on. But if you shift that logic to a CI/CD environment, so if you're using Jenkins or if you're using GitHub Actions, you want to test against a fresh install of your application, so you're going to be running npm installs there. Imagine being able to reduce that time and save on GitHub Actions minutes if you're being charged per the minute, or if you have a Jenkins server where you can only run 5 jobs at a time. Being able to reduce that time going through those processes enables you to go from installing a package, fixing a bug, shipping it to customers, and it's all about that kind of reducing the small parts of your kind of workflow. So then the other thing that we probably use regularly enough is npx. So I use npx if I'm trying to serve up a local folder. We've seen examples actually earlier where you can use npx to run ESLint if you don't want to actually install it into your project. And again, BUN has thought about this. They provided BUNX. It's the same sort of concept. You can run an npm package without actually having to really install it on your machine. It technically does, and then it disappears whenever you're done. So let's take a look again, an example. So we have BUN and npm against each other in this case. And in this case, we are creating a Next.js application. So we're doing npx or bunx, create next app. And we can let this run through, but we'll get to the data because that's the more interesting side of things. So again, we see this chart. And surprisingly, in this case, npm came out faster, which I was very shocked about because I kind of assumed, like, well, Bun's meant to be fast. It's fast everywhere. This was the first run, and I was taking the first run as, like, the source of truth because I wanted to, like, verify, like, this is my first impressions using it. If it's not fast on first impressions, I'm not going to continue on with it. I don't want to give it the capability to say, well, on the third run, it'll be faster. I wanted to run fast in the first time. Not by a huge amount. We're looking at, like, 38% difference here, but it shows you that Bun kind of fell behind a little bit. So maybe in this case, we stick to npx and wait for bunx to improve. Maybe my machine was running slow at that time. There's a lot of factors into this as well. So we've been kind of talking about how Bun is a replacement for npm and Node, and like we've been using those tools for years now, and there's a lot that we've grown to love and appreciate, and we use it daily all the time. But Bun, again, has thought about this. So Bun had a 1.0 release recently, and they shipped all these feature set into that. And disclaimer, I'm not connected to the project or the team whatsoever, so these are my opinions. I could be wrong with some of them. So some of the kind of cool features that they delivered out of the box was a watch feature. So you can automatically watch files in your file system, rebuild your application, rerun it. It takes away that need to have like node mod or something else that we've been using recently to kind of do these things. It's got fetch built in, so I know that Node brought this in the last couple of versions, but having this out of the box in this tool means you're not having to think about it and worry about it. You're not having to maybe install packages for legacy applications. It also comes with a transpiler. So if you're reaching for the likes of JSX or TypeScript, you don't have to think about configuring something to make that work for you. It just works out of the box through whatever magic they kind of do under the hood. So we're not having to think about configuring the TypeScript compiler. We're not having to think about configuring like a transpiler to bring in a JSX file and convert it into JavaScript for us. We can just use it out of the box and work and get off the ground quickly. And kind of following from that, it has a bundler built in. So it's kind of clipping at the heels of the likes of like Webpack and Turbo and Vite. It's modeled very much off the ESBuild bundler. So if you've used that in the past or you have plugins that you regularly use, they will most of the time kind of merge over and work out of the box. But having that bundler built in gives you that kind of peace of mind that you don't have to go and configure something. You don't have to go and do something else. It's just there for you in the tool system. So you're not having to think about, right, do I have to like go and create a Webpack config? Do I have to like choose between ESBuild or Vite? It also has hot reloading out of the box. So I'm one of those people who's had to configure and handwrite Webpack configs multiple times to get it to hot reload, and it never hot reloaded the exact way I wanted it, and it worked sometimes on some people's machines. But Bun has built this into the ecosystem so you can configure, and it's like a couple of commands that you just pass it, and it'll manage to like read your code, hot reload into the browser. You don't really have to think about it. It takes a lot of the away from you. And then finally, they added in a test runner. So obviously, Node added a test runner recently, and it's still being built out. Bun thought, right, let's build that in to the 1.0 version. And they've really kind of thought about like what were people using for testing beforehand. So it's modeled very much off the kind of jest pattern. So like a lot of people are writing tests in jest, so they kind of went for that market, and it's very compatible towards that. Another great feature that Bun kind of thought about when they were building this out is we're going through a shift in the ecosystem, and we're moving from CommonJS modules to ESM modules to kind of mirror the imports in the browser with the imports on the server. And it is a very difficult transition for some people. You're importing older packages, you're importing things that aren't working anymore. So how do we manage that together? Well, Bun's thought about this and says, let's not make a difference between the two of them. We understand what they are, we understand how they can work. So now you have the capability of saying, I can do an import and a require in the same file, and it just works. I don't have to configure anything. I don't have to tell Bun anything. It knows I can do that automatically, so just do it for me. So you can mix and match. And I think that this is actually going to help with that transition from CommonJS into ESM, because people won't be running into the roadblocks with older packages, and they won't be saying, well, I'll have to stay on Common because I need to support these packages. Whereas as those packages update, you kind of just like bump the version, and suddenly now it's all ESM. So again, it's still like we're replacing npm, we're replacing Node, so we want to like run commands. We want to do npm run build, run dev, run test, whatever. And again, with BUN, you get BUN run. So whatever you can run with npm, you can run with BUN. So in this example, we are running the dev version of that Next.js application that we created. And we can kind of see here, yes, it's a very small difference, and it was a very quick startup on both of those. But we're looking at like a 22% increase when we use BUN, like in speed, let's say. So getting your application started quicker is just helping you along the way to like tackle these problems. So imagine like you're installing faster, you're running faster, you're building and fixing problems faster. So we mentioned earlier about the BUN test runner. Just kind of delve into that a little bit more as well. So some of the key features of the BUN test implementation, or test runner, we want to call it, is it's got Jest compatibility, so not fully compatible with Jest, but if you have a suite written in Jest, you can migrate it across with very little issues. You might have to modify some things, and the team at BUN are working to have a one-to-one compatibility with that. It's got TypeScript baked into it, so if you've ever tried to configure Jest to run TypeScript, and then it's like, I need to use test Node, or how do I run those tests? You can now write your code in TypeScript, you can write your tests in TypeScript. It also has JSS compatibility, so again, I hate configuring things because I never read the docs. So being able to just use these things out of the box is really great for me. It's got snapshot testing, so if you're dealing with large data sets, you can easily snapshot those. You're not having to like, write tons of manual specs. It's got its own DOM testing library, so if you're maybe outside of the React world and not using React testing library, but you have a DOM implementation, you can still test against that. And then it has a watch mode that I kind of wanted to add to the slide, but it's such a buzzword. It's like a blazingly fast watch mode, but we'll get to see that in action. So what does a test look like? Very similar to if you've ever used Jest or any other little testing libraries. You import expect, you import test from BUN, and then you use them as you would. Create your test, give it the test case, run the test. And the output is very similar to like what we would see if we were running a normal test runner. So nothing's crazily changed. We're all used to that. It fits into our workflows very easily. But then when we go into the watch mode, so this is me running BUN watch, and we make a change to this test, and the output on the terminal is almost instantaneous. When I was recording the GIF and I was kind of looking from the IDE over to the terminal, I thought it wasn't actually working because it hadn't updated. Or, well, it did, but I didn't think it updated. It was that fast. So getting that super fast update and super fast interaction allows you to kind of like move quickly. And obviously, this is running against one test, but this does scale. And the examples that the BUN team have kind of provided, like it will grow and scale with your application. For comparison, like we can look at like the Jest version of this. Again, it's not hugely slow. We're not talking like minutes here, but there is a noticeable lag where we break the test, and Jest is kind of like thinking about it, whether or not it's going to tell you it's broken, and it's kind of churning and it's holding there, and it's like, right, okay, let's go for it. So obviously, we mentioned a lot about like npm commands and running npm commands, but what about when it comes to actually like the Node compatibility here? So obviously, we want to replace Node with BUN. So what is like the kind of level of coverage that they have in this? So I've kind of broken down the APIs that BUN has covered, that partially covered, and that don't cover. And we kind of look at the chart, like, and it's looking quite well on the actual coverage side of things, and this will grow over time. So we're looking at like just under 70% fully covered APIs. So that's your FS modules, all these kind of things that you can that you're used to using, and so you can just drop in BUN as a replacement. We have about 12% that is partial. So this could be the case where some of the functions are covered from that API, but not everything's covered yet. And they are working through and trying to improve that kind of stuff. And then we have like this percentage where it's not covered. There is some modules that will just never be covered for valid reasons. So Node has APIs that allows you to talk to the V8 engine. Obviously, BUN doesn't use a V8 engine, so there's no real need to have those APIs implemented. So there's going to be ones that will just never be covered. And this is something to think about in your application when you're saying, can I use this? Are you using things that are tailored specifically to the V8 engine that you might not be able to port over the JavaScript core engine? So kind of think about how that's going to work for you, and is that valid for your use cases? So as well as BUN covering the core Node APIs, BUN has been starting to add its own APIs to kind of improve and help you do different things. And because they're all focused on speed and it's all underpinned by that Zig programming language, it does give you a good speed boost on your kind of operations. So let's take a look at some of those. So the first one is the BUN file API. So in these 3 lines of code, I'm reading the file from the file system, I'm printing out its text, well, I'm reading this text into a variable and I'm logging that out. Like, I think it's astonishing that that is 3 lines of code just to read a file and print it out. Like, if I was doing this node, I kind of think, right, am I using, the sync, read, like fs sync, or am I doing asynchronous reading, and then having to feed it a callback? We simplify down the code so much that it just makes it so much easier to work with. And what I like about it as well, all the BUN APIs are like asynchronous first. They're forcing that kind of asynchronous operation on you, so you don't get caught out with these, random edge cases where you're reading from the file system while another file's being modified, or breaking your user's experience in that kind of way. And to kind of correspond with that, we have the write API. So again, this is broken down into 3 different lines, just so I can fit it into that part of the slide, but that could be 1 line. In 1 line, we're writing a file to the file system. So we're able to just call it the bun.write. You give it the name of the file, or the path as well. And then you give it what the contents are. And they accept a couple of different contents, but I really find this one interesting where you can give it a asynchronous function. So we can fetch an external website and then write that to disk in 1 line of code. So simplifying all that down. And this could be great if you're building out web scraping tools to kind of read files from other servers. You're not having to worry about fetching the file first, parsing the file, doing this, and then passing through. BUN understands what you're trying to do, and it just kind of does it for you. BUN also has a serve implementation, so it can run its own web server, and this is kind of nipping at the heels of the likes of Express and Koa and these kind of frameworks that we use in Node to build up an application that we can use as a web server. BUN is kind of targeting that market. So again, in a couple of short lines, this is a very basic web server, obviously, but you could build in routing, you could build in all that kind of error handling. But it's kind of keeping it simple, keeping it fast, and it's loading it up instantaneously for us and accepting a lot of requests. And then the last one of the APIs they've implemented is a password hashing API. So this is just kind of showing that they can do heavy mathematical operations, so we can create passwords and we can validate passwords. If you're building your own auth, which you probably shouldn't be doing unless you're an auth company, or you're working in the kind of crypto Web3 space, being able to generate these hashes could be really useful. So we've kind of looked at BUN as a drop-in replacement and how it's kind of going, and we can see the ability that we could fill in the gaps in the APIs, and it's already looking like we could just drop this in and run with it. But what is the future of BUN? So they have an open GitHub issue with all the features that they currently have supported and features that they have in the future. There's no timeline, and there's no guarantee that they'll actually happen, but I picked out some of the ones that I was kind of excited about. So one of the kind of key ones I looked at and I saw was there's potential, again, none of these actually might happen, for first-class support for Next.js and Remix. So taking those heavily server-side rendering applications that we're moving towards at the minute and putting them in the BUN ecosystem to make them render faster, load faster, respond faster. BUN already has a SQLite client, but they're potentially going to be expanding out into other clients. So there'll be a MySQL client and a Progress client. And this is just kind of expanding your options when it comes to how you can interact with data and use database connections in your application without having to reach for a third-party module. And then finally, one that's kind of interesting to me is the HTTP and HTTPS support. So this is kind of leaning towards how Deno does its imports. So potentially you could be importing from a URL, importing from a file, and requiring from a file into one file. So in conclusion, should we all run out the door right now and start replacing BUN and replacing Node and NPM with BUN? I'm very hesitant to say yes. I don't want to be the person you're going to blame on Twitter over this stuff, but I never check Twitter, so it'll be okay. I think for local dev, it's a no-brainer that you can replace any NPM command now with a BUN command. So the installs are going to be faster, running your local dev server is going to be faster, running your tests is going to be faster. Imagine the saves you can have on how long a GitHub action takes or how long a job on a Jenkins server takes to get you from right, we found a bug in production. We need to install it locally, fix the bug, ship to customers. Reducing all those times along that pipeline enables you to build faster, deliver faster, fix those issues faster, so you're not getting complaints and you don't have downtime. So I think local dev, definitely. If you're brave and you want to replace a production application, do it at your own risk. BUN has hit 1.0, so that should be stable, but tools need time to mature and grow, and there will be edge cases that are going to catch you out and those kind of things. So thank you very much. Hopefully that's inspired you to look into BUN, and hopefully you've kind of learned something about BUN if you've never heard of it before. And I hope to see the future of BUN, the future of JavaScript change over the years. And then that is obviously me done.